Just want to say hello to everybody who just showed up. We're starting about 5 minutes. Give everybody a bit of time for anyone who's running late. If everybody just put a 1 to chat if you came from Meetup, so I know that that link is working and that you can hear my audio, that'd be awesome. Yeah, I'm just gonna ask one more time. If somebody could just put a 1 into chat if you can hear my audio and you came from Meetup. So I know that the Meetup link is working and my audio is okay. Awesome, thank you. Cool, yeah, so we'll just give it a couple more minutes. Just kind of waiting for anybody who's running late. We do have a bit of an accelerated schedule today, just because we have another, I've got to be on another webinar at 6. Someone accidentally scheduled it on top of my webinar, so that's okay. But usually this goes till 6:30, so it's only going to go to 6 today. So it's going to be a little bit quicker, and I can, at the end, if anybody wants the video, because I'm going to move pretty quick today, if anybody wants the video to review, totally happy to send it to you. Next week will be a bit of a longer session. I like to give a little primer on machine learning at the end, because machine learning, it's, if you guys have heard of artificial intelligence, then machine learning is sort of like the core, I would say, technologies driving our most successful artificial intelligence systems right now. So I like to kind of just do a little introduction to that, like a little fun 6 or 7 minute introduction at the end. Probably won't get time today, which is unfortunate because it's the best part for me. So yeah, if you want to join us next week or anything like that, for sure let me know. So actually, you know what? With that, usually I like to wait until everybody gets here, but I think we're just gonna have to get right into it because we do have to finish up by 6. Okay, great. Again, if you have any questions at all, please chat them in. Could anybody put a 2 in if you are following along? Excuse me. If you're following along, writing the code, what is the contact of the recording? What I'll do is I will post it in the meetup comment section for this one. So I think you'll have to go to like past meetups. And if you can't find it, I'll write my business email in here. There we go. Cool. Yeah. So that's also my business email. If you can't go to the past event and meetup to find the comment, which will have the link, then you can just message me there and I'll make sure I get it out to you. Cool. So without further ado, and I'm sorry, I do have a bit of a cough, so every now and then I might break out coughing, but cool. So we'll start off with a little bit about me, a little bit about you, some stuff about Python, jump into the Python, and we'll talk about some cool steps and next stuff if we have time at the end there. So yeah, we're Cloud Ready. We're a Toronto-based startup which was founded in 2015. We both make like commercial products that we sell in the marketplace. Recently, we used some machine learning to build a SKU caster, and the SKU caster basically it takes retail inventory levels and it predicts how much stock people will need in some time series going out. And so as people who like retailers can better predict how much they're going to sell of items, they can order more accurately, which basically frees up a lot of their capital and at the same time, lets them avoid out of stock situations. more accurately. So yeah, so we do that. We also do consulting as well for things like cloud migration with AI, or sorry, with just IT sphere cloud migration stuff. And we also do training and placement. So we like to teach students and help them out, and then try to get them jobs because working in tech is a good thing to do. This is a survey. I'll post at the end if I've got time, so you guys don't have to copy that link or anything like that. So let's just jump into Python. If anybody minds, would you mind just typing in a 2 if you're following me writing the code? That will kind of change my pacing a little bit, because otherwise I'm just kind of explaining the concepts and you'll see me coding. But if you are following along, then I will slow down a little bit. So if you don't mind, again, just typing in a 2 if you're actually going to try to write the code. Like if you went through the videos, you installed Pycharm, you've got Python on your computer, then yeah, please type it a 2 in right now. And yeah. Also, another thing, if you wouldn't mind doing, is if people are like quite strong in a different language, but you're just interested in Python, please type in a 3. So, if you're like a Java developer, or, you've been writing, I don't know, statistical stuff in R for a while, and you're just kind of curious about Python because everybody talks about it, please type in a 3 at that point so I can know that, because that makes me go a bit faster if you get a bunch of 3s. And yeah, so what have I said so far? A 2? What was a 2 again? I can't remember. Okay, 3 if you're strong in another language. 2 if you're coding. If you're coding with me, please type in a 2. And yeah, just waiting for some people to chat into me, please, please, please. Because just before we get going, I would love to know. So, and I guess 1, if you're a total beginner to coding, total beginner to coding, please type in a 1 now, right? If you're following along, please type in a 2. And if you're, okay, so we've got somebody who's good at another language, but they don't know Python. But I've only got 1 response so far, and there's a whole bunch of us in here. So please type in. I'm going to do this one more time. It will affect how fast I go. So 1 if you're a total beginner, 2 if you're following along with me in the code, and 3 if you're strong in a different language but you don't know Python. Right? I'm sure there's more options. I don't think that's exhaustive. But that's what I've got. Okay, so I've got a bunch of 3s. Okay, so we're going to be moving fairly quickly. No 2s and no 1s. Okay. Great. Okay, so Python. So some high-level ideas. It's very easy to use in comparison to other languages. So all you 3s, you've been probably working with much harder languages, really depending on what you're working in, to be fair. So basically the syntax is quite simple. It's a lot of people talk that they can be writing code as fast as they, basically as fast as they can think up, like the logic, you know what I mean? Almost as fast as you write in English, they're just hammering out the code. Okay, I've got a couple 1s in here. I will end up slowing down a little bit. Okay, great. So yeah, so anyway, it's very easy to use in comparison to other languages. Python's very extensible, and extensible means that if you want to go solve some project or you want to go solve some problem using Python, you'll basically be stringing together a bunch of other people's code. That's the way you do it these days, because other people write code that will do things that are much more interesting, like let's say handle spreadsheets, or I don't know, create graphics, anything like that. Like you're not going to code that stuff from scratch, because if I want to make something do graphics, I would actually have to give like the computer pretty low level instructions about how to like change pixel colors on the screen, and that would really take a lot of like math. It would be very hard depending on how complex it is, of course. So instead I would use somebody else's library to do graphics for me. And similarly with, let's say, spreadsheets, it would probably take like a lot of math and a lot of like database knowledge to do that. So instead I'll just use somebody else's code to handle spreadsheets for me. So basically I'm just kind of stringing together other people's codes. So Python's very powerful because the community is really great. There's been so much different code written in it that there's probably some kind of library out there to solve whatever task you need. And it's really generally fairly easy to use. Like it's like once you understand core Python, the other libraries you're going to be downloading are going to follow a similar structure to core Python. And so you don't like, yeah, it's really easy. It's not like learning another language to use a library in Python. It's just understanding the library itself. So it's really wonderful. It's very sought after by employers, of course, because um, it's just such a very popular language. You can do everything in it, like I was saying, and the community is amazing. So Stack Exchange, GitHub, documentation, YouTube. If you're not sure what those things are, well, I'll just go quickly through it. But so Stack Exchange is a place where you can get very technical answers. So people from universities and whatnot, they can universities, big tech companies, who are expert at, like, let's say Python, they'll look at your Python bug, because you will have, of course, bugs and errors when you write your code. And even if it's a very like a nuanced, subtle situation that no one's ever encountered before, they'll like figure it out for you, just like give you the answer for free, which is incredible. But it's, it can be pretty intense for beginners. GitHub as well is, yeah, we won't probably touch on GitHub today. We don't have time for that documentation. And of course, the YouTube community around Python is amazing. So if you're a beginner, anything you want to learn, just go to YouTube, type it in there. I really suggest if you use Chrome to install a video speed player changer. Basically, I think it's an extension. Anyways, you can speed up your videos like crazy, and you can just fly through learning Python that way. So that's really great. So learning tips. I don't think we're going to get into this too much because yeah, I don't think we really have time today, but basically I would just say that don't be overwhelmed, especially if you're a beginner. I do have a couple ones here. If you're a total beginner, don't worry about um, understanding everything you see. So I would say just like, if I were to use Word, like Microsoft Word to write up a document, I don't understand half the options in Word. It's like, because I have never used them or needed to use them before. So similarly with coding, just, we'll show you the stuff that you need to know, and then you just kind of ignore the rest. And one day you'll probably, if you go deep enough, you'll learn it. Otherwise, you'll be fine without it. So, yep, okay, cool. So let's moving on. This is just a little progression about how to get help for beginners. This should be a progression instead of like a grid. But starting up here, YouTube's the easiest and the slowest way to get things. Then if you Google full tutorials, that's getting faster. Stack Exchange is getting pretty quick because every question, every problem you've probably had has probably already been asked, or someone else had that problem and asked the answer on Stack Exchange, but it's pretty technical. And then of course, last but not least, is documentation, which will tell you exactly how the code you're looking at works. But it can be kind of when you're starting off coding, documentation is pretty overwhelming. So you definitely don't want to start there, but you just kind of want to work your way along there. Help. Cool. All right, let's dive into Pycharm, and we will get this tutorial going. Cool. Okay, so I didn't get any two, so I'm not sure if people are following along, but I hope you are, because you'll get a lot more out of it. And so if you are, I hope you're seeing this. This is just Pycharm. It's an IDE. It was just an interactive development environment, and basically it's a program that makes writing code easier. So similar to writing an email, I could write it on a piece of paper or a notepad, or I could write it in Gmail. Obviously, Gmail is going to have way more formatting and options, and it's just like spell check for me. And like a notepad will have none of that, and obviously a piece of paper will have none of that, and I would have to, you can't email a piece of paper, but I guess you can mail it. So anyways, I think you get my point. An IDE is just something that makes it way easier, because you can obviously write your code in Notepad as well, but it's not going to do all the cool things this will do for you. If you are seeing this, basically this is on the side. It can be overwhelming, of course. This is just like where the files are living in your computer. So if you're not, you can just go to File, and you can go to New, and you can choose Python. You give it a name, and it's going to show up over here, right? These are your libraries. We'll come to libraries at the end. This is just your kind of like Scratchpad, rough work stuff. And yeah, that's pretty much it. This is your IDE. So we're just going to jump in, and we're going to start off with our first program. We're going to print hello world. I switch keyboards quite frequently, so my accuracy is not so great. So don't judge me. Anyways, okay, so we're just going to go like this, and then the first time we run it, we've got to right click on the file. So this is Python tutorial. I'm going to come up here, I'm going to right click on it, and I'm going to run Python tutorial, and it's going to output the code here. So let's just kind of go through what happened here. So when you're programming, basically you're giving the computer data, and you're giving the computer rules about how to manipulate the data. So, and then what the computer is going to do is it's going to take your data, it's going to take your rules, it's going to go do whatever you told it to do with the data, and it's going to give you some new data back, right? It's going to execute some kind of operation that'll give you some kind of feedback. Cool. So basically, what we've just done here is this is called a function, right? And a lot of people in here will know this, but this is just a function, and this is just a set of rules. So this is basically when you write this into Python, there's a bunch of code behind this that someone else has written, that when you say print, it's gonna go look up that code, and it's gonna use that code. Now the next thing is, this is just syntax. These brackets are syntax, and syntax is just like in English, where you have to use periods and commas in certain places for the meaning of your words to be understood. Just like in coding, you have to use certain things that, like, they're kind of just pieces of code so that the computer understands what you're trying to talk to it, and that's syntax, right? So the syntax here is you have a function, and you're going to put your brackets, right? These kind of brackets, and you're going to put the data inside. So this is just the data here, right? And so this data is hello world, but I have to put these strings on it so that basically Python knows that it's data, right? And so we go to run here. What happens at the end is this is just where on my computer the file is, so there's nothing to be too afraid about there. This is just that's where it lives. Then that's the output. So what it did, this print function, right? It's a set of rules. There's some code here, and so you give it some data, and what it does is it prints the data. So that makes all sense. And then process finished with exit code 0, just meaning that there are no exits, right? If I go ahead and I break this, I mess up the syntax. The nice thing about the IDE is it's going to give me a red error here. It's going to give me a red error here, right? So I know there's already error in advance, and then when I go to run it, it's going to give me a syntax error, basically just saying, you forgot one of your brackets here. And so it gives me error code 1. So error code 1 means there is an error. Cool. Okay, so then I'm going to put my bracket back in here. Yeah, I hope there's no questions about that. That's pretty much it. One of the things that we have to do is, so I'm kind of moving a little bit quick here today. I don't know if people caught that before, but I am instead of going to 6:30 like I usually do, there's a bit of a scheduling error, so I've got to be done at 6. So I'm moving a little bit quickly. So what would I usually also say about this is basically just that we have to use a print statement, because generally when we give instructions to computers, like obviously all the programs we're all running on our computers right now, like there's so many programs running on your computer all at the same time. If they're always telling you what they were doing, you'd be drowning in messages. So they don't tell you what they're doing, they just go do it, and then you only know because you're getting feedback from it. So in this case, we want to tell our program to say, like to tell us what it's doing, and that's what we use the print statement for. Great. Okay, so the next thing we're going to go is we're just going to go I am comment. Right. And so when you're writing code, you definitely want to leave comments for yourself. I've been on projects in the past where it was very poorly documented, and by documentation I mean comments here, and other forms of documentation, but like any documentation. And I basically, by the time I figured out what the project, like what the code was doing, and like it was full of bugs and like what it should have been doing, I could have just rewritten it myself, and that would have probably been faster. So similarly, if you write code, it's kind of complex, and then you're going to go away from it for like a week or a month or just some amount of time, you're going to forget what all that complex logic that you figured out was, because basically coding is just you take some goal, right? Like I don't know. So you take some goal. Like I wrote a script to help a friend. She does bariatric research. So basically, bariatric research is for people who have health issues related to being overweight, and they get a surgery, and that helps them lose weight. And so anyway, she's kind of like a manager and stuff like that. And so she was like looking through all these patient files and stuff. And it's very tedious, 3 hours a week kind of thing. So I just wrote her a script to kind of like go through her files and do her job for her. And like it takes obviously 4 seconds to run, and it just kind of saves her a whole lot of time. Why did I mention that? Basically, so if I have this idea of, I want to help my friend, I have to break that down into like, how do I want to help my friend? Exactly, what are all the little steps? I'm gonna break this down to all kinds of little micro steps, right? And so if I go back and had to figure out all these micro steps again, I might as well just rewrite the code. I wouldn't have saved myself any time. But if I have nice comments like this, then I never have to. I can just be like, oh, that's what this does. Like this obviously comment is not very descriptive because it's just I am comment, but in the future, like that's my point is use comments to save yourself lots of time in the future. Okay, great. Moving on. Cool. So we're just going to get into variables and data types. Okay. Great. So we're going to go with a string. So we'll say name equals Nicholas, and we're going to go with an integer x equals 5. And we're going to go with a float y equals 0.14, and then we'll go with some booleans. And I'm just going to type these out, then I'll come back and explain what they're all about. True, graph equals false. Cool. Okay, so yeah, so in Python, you don't have to explicitly declare what your data types are going to be for your variables. So if you're programming a different language, that will make sense to you. If you're new, basically, like I've been saying before, is when you go to program, you are going to give the computer some data and some rules, and then it's going to go, it's going to go execute those rules, give it with the data you gave it, and it's going to give you some data back, right? It's going to do some operations. So basically, variables are kind of like the simplest way that you can store data in the computer. Right now in math, variables are kind of like unknowns, and they're they kind of are spooky kind of things maybe. So in this, it's just you just think of them as buckets. Like it's just like super simple. It's just like a bucket you're going to put some information in, and that's pretty much it, right? So in this case, name is a variable, and x is a variable, and y is a variable, and I'm just putting things in them, right? In this case, I'm putting inside of name, I'm going to put Nicholas there. Inside of x, I'm going to put 5 there, and that's the way it goes, right? So basically, the way Python kind of reads it is like, okay, what's the data? And then, okay, equals, where is it going, right? And so now somewhere in the memory for this, then there's this variable that's associated, this variable name is associated with Nicholas. That's pretty much it. And why you use variables, I can kind of touch on that a little bit later. But if you're brand new, just trust us that you don't want to type Nicholas over and over and over throughout it. You just want to use the variable name over and over and over for a lot of reasons. Cool. So anyway, so those are variables. Then beyond that, we've got data types. So data types are Data types are very important because Python needs to know what kind of data it's dealing with, because basically you're going to treat certain types of data different than other types of data. So for example, I can do with let's say an integer. An integer, if you don't remember from math, it's just a round number. It can be negative or positive, but it doesn't have any decimal points. Whereas a float has decimal points. And I think they call it a float because the decimal can float around, kind of like what I'm doing right here. Right, the decimal point can kind of float around. I'm not sure. I think that's why they call it float, but I'm not sure. Anyways, so yeah, so there's different kind of data types. But let's say you're dealing with an integer here. Well, like if I want to take, let's say, this integer to the power of 2, 5 times 5 is equals 25. That makes sense. But Nicholas times 2, or sorry, Nicholas to the power of 2 doesn't really make sense because it's not a number, right? And these operations that we want to do with math, they don't really make sense if we're using like English words, for example, right? So Python, although you don't have to explicitly, like in other languages, I would have to say something like str name equals this because this is a string. So I would have to declare this as a string, and then I would give it the variable name, and then I would get the data in. Python kind of just figures it out on its own, which is really, really cool. Really, really nice to program it, but it still does need to know what they are. So cool. So we've kind of seen 4 different types of data here. So strings are just words, basically. They can be obviously any language, but they're not numbers. That's the thing about them. You can have double quotes or single quotes. You just have to be specific, or you have to be consistent. These are obviously, this is a kind of number within a decimal, number with a decimal, right? It's floats, and then Booleans are just true and false. And so there's, excuse me, there's definitely more data types in this, but these are some good kind of like fundamental basic ones that you're going to see all the time. And if you know these, you can still do some kind of cool stuff. So cool, let's get into, just going to run along here. Oh yeah, so I'm just going to show you guys some functions and methods. My goal here with this tutorial is just so that someone who is completely from the beginning, can go and they can kind of have a bit of familiarity with Python so that they could start like learning on their own kind of thing, right? So you can go out and you can be like, okay, like I would like to make a little program or something, and you've heard enough terms and you've seen enough stuff that you could kind of work with it on your own. That's my goal. So sometimes I'm going to show you things and you'll be like, why? Like that's not very interesting right now, but the point of it is so that you could go do your own thing. So cool. So functions, like I mentioned, like print is a function. Then the syntax is we'll put the data in here, and it's going to print something out. I'm just going to go up here and I'm going to comment this out so it's not printing that every time. I'll do another function called len. Len name. If we go and we run this, click up here and run this. So at the start we had to right click and we had to go, or at the start I did this, I think go right click and I went run. In this case I can, because I ran that last time, I can just run it from here. I go shift F10, shift F10. Cool, so anyways, so now I've run this function and it's gonna print 8 out for me. So basically it's saying there's a function called len, and that's just gonna count how many characters are in something, right? So there's 8 characters in my name and it's gonna print out the number 8. Cool, there's just so there's every kind of function you could imagine exists in Python. So if you're ever just like, oh, I'd like to add a bunch of things up, or I mean, just anything you can imagine, you just throw into Google and it's going to be there for you. There's going to be there's a function that does it. That's a function. The other thing I want to show you is I want to show you something called a method, and methods are just like functions, but they come off the back. It's kind of like a silly way to say that, but so I'm gonna print this out. I'm gonna run this, and so basically, this is a method. I'm gonna hopefully explain how that works. So function, you'll notice that just like print, you open the brackets, right? Or len, you open the brackets, and then you put your data inside there. In this case, the data is name, but obviously the name itself is not data. Name is a variable, and that variable refers to data. So when this goes to execute, when we go to run this, Python goes and says, okay, well name, I don't know what that is, right? But it's not data. So it's going to go up here and it's going to look and go, oh yeah, name, okay, that's Nicholas. It's going to pop Nicholas in here. And then it's going to be like, okay, what does the len function do, right? It counts how many characters. And what is the print? So then that's going to turn into 8. And it's going to print that and get 8. Okay, solid, right? Methods are very similar. They just have a slightly different syntax for calling them, but they're also, you could also think of them as functions, but people just call them methods, fundamentally. So methods, they come off of basically, they're usually tied to some sort of either like a library, or in this case a data type. I'm kind of dancing around the idea of talking about objects and stuff like that. So if anybody If anybody's wondering if I, do know what objects are, I do. But for the beginners, I'm dancing around those ideas. So basically, in this case, all it is the easiest way to think of that is it's also a function. But what this function did is it has a string here, so it knows that name is, my name Nicholas. But then that is a string, of course, like we've talked about. This is a string. It's a string of letters. So this is called a string method, where as long as we have a string here, we can then do a dot, and then we can call a function off the back of it. And maybe the easiest way to think of why that is because this function is only going to work with strings, right? So it needs to have this string dot this type of function, whereas len will work with anything, print will work with anything. I'm not sure that's the best way to think of it, but let's work with that for now. In this case, you've got a string here, and then you've got this method, right? And so I can kind of show you that, like, for example, if I've got my string here again and dot, the IDE is doing autocomplete, where it's going in and it's looking at all the different kind of functions, right? That could be coming off of a string, that could work with a string here, right? So yeah, there's basically like, I'm not going to go through all of these, but there's just a lot of different functions here, but they all work with strings. Cool. Okay, so I just want you to know that when you're thinking about these rules that are going to work with the data types, you can have the ones that just basically are here and you can put the data in, or you can have them come off the back like this. Okay, cool. I hope that was somewhat clear. Cool. Okay, so let's go on to if statements and control logic. Cool. So this is kind of, I recently heard someone talk about how in the past we made machines to help us with our manual labor. So that would have been like, like steam engines and, just all kinds of tools that would help us do physical jobs. And then we started kind of making computers to help us with our intellectual or our cognitive labor, right? So like calculators, for example, and then like more and more complex things that obviously have surpassed human intellectual ability. But one of the kind of ways that you're starting to make computers get a little bit smart and be able to help you with actual tasks is to give them basically control logic. So in the form of like if statements. So what do I mean by that? So basically, if I said to like a friend of mine that's like, I'm going to take a nap. If it's after 5 p.m., please wake me up. Right? Let's say we're going to go running together or something like that. That's kind of that's an if-then statement. So that's kind of like some control logic, right? And if you need computers to be able to do that, right? So for example, I was talking about this script I was writing for a friend of mine. And let's say she's looking at patient information, and if their blood pressure is a certain way and something else is going on, then you want to make an appointment for them, right? So that's a bunch of control logic too, right? And that's how we think a lot of time. If this, then do this. So obviously having that kind of functionality in a programming language is very important. And on top of that, like, it actually lets you start to make kind of smarter little programs. So let's just kind of get into that, right? We'll just kind of do some silly little examples here. We'll go like Python equals true. And like Netflix equals true. Excuse me. Okay, so we're going to go if. So this is just syntax that we're going to see. You're going to see the syntax a bunch of times. We're going to start off by going if, like Python, and then you've got the autocomplete, so I'm going to press enter, colon, I'm going to say print Python is great. There we go. I'm just going to come up here and I'm going to. So if you highlight these in control backspace, then Pycharm will comment them out for you. It's kind of just a nice little quality of life thing. So I'm going to print this and I'm going to Python's great. So what happened here? So basically I'm creating some Booleans, right? We mentioned that these are a type of variables which can only be true or false. I didn't mention that, but I should have. So Booleans can only be true or false fundamentally, and obviously that's something we reason about a lot. You know what I mean? Like, is it raining outside? Well, that's going to be a true or false kind of thing, right? So in this case, what we do is I've created another Boolean, and I'm saying like Python, and that I'm going to set that to true. And so what this if statement does, it says if this Boolean is true, right? In this case, it is true. Colon, come down here, and I'm going to execute this code block here. Now this is just called a code block because basically it's basically it's under control of this if statement right here. Cool. So just kind of some things about the syntax here. Obviously you've got to go if, then you have to have a Boolean, right, or true or false, then the colon, and then you need 4 spaces here. So if I don't have these 4 spaces here and I run it, see I'm getting my error up here. So it's an expected and indented block, indentation block. Anyways, so basically you just need 1, 2, 3, 4 spaces. You know what I mean? Or you can tab it over, and that's just what it is. And then you're going to run that. It's going to go here. So obviously, if I change this to false now, it's going to run this, and it's going to just do nothing, right? So if false, just ignore what's down here. Cool. So now what I'm going to do is I'm going to go if, like Netflix, I'm going to say print priorities. Man. So our guy's very snarky and maybe a bit on the lazy side right now. So he's going to go, unlike all of you, which is lovely. And so basically what happened here is it says if like Python, then okay, well it's false, so don't do that. If like Netflix, okay, yeah, well that's true, so let's print that out. Okay, so now what's going to happen is if I change this back to true and I run them, I think you can guess it's going to do both of them, right? Here's true, okay, let's do this. Here is true, okay, let's do this, right? So what if I want to do though? What if I want to do something like this? What if I just wanted to check the first one, and if that's true, do that, and then don't go any farther, right? So in the case somebody might come up to you and they might say, it might be someone offering you something to drink, and they might say, would you like some tea, right? And then if you say yes, they're not going to ask you if you want coffee. They're just going to give you tea. They know that that's what you want, right? So they're not going to keep going on the list, but they might say, okay, do you want tea? No. Do you want coffee? No. Do you want Pepsi? Okay, yes. And they're going to stop at Pepsi. They won't go to Coke and all the other things. I think you get my point here, right? So the way that we're going to do this is we join these two things together by doing an elif like this, right? So now, when I go to run this, I'm going to say Python's great, right? Because we've got this true here. If true, print Python's great, and then don't do anything else after that. Just like that, right? Like, do you want coffee? Yes? Okay, I'm not going to ask about tea, kind of thing. Cool. So those are related, and obviously if I make this false now and run this, then we're going to get priorities, man, because we don't like Python. We don't want to study. Cool. Okay, and now we're going to do one more thing. This is kind of like the end of control logic right now. I'm just going to go ask me later, please. Great. So we're going to run this, and we're going to see just priorities, man, again. Because now we did this, right? Came down here. Well, false. Okay, keep checking. So just ignore this, keep checking. This is true. Okay, great. Let's stop there, right? But now if we make this false, we've got this else statement. We're going to see ask me later, please. So what happens is this went down here and it said this is false. Okay, don't do that. This is false and don't do this. This else statement, it's just kind of like it's a catch-all at the very end. And it means that you'll notice that there's no Boolean here, right? This just means if everything is false above it, always do this, right? It's just like the last case scenario, always do this, right? And you can think of different ways. Maybe maybe if I'm creating some kind of thing that checks if a password's correct or not, maybe my else statement is the password is false, right? So like unless I find some condition that is going to be true along the way down, you know what I mean? I'm checking and find some condition that's true along the way down. I always tell the person at the end it's false. I always tell the person at the end that they've put the right password in. Something like that. You can kind of think of these things, right? Or again, going back to my silly tea and coffee example, like, do you want tea? No. Do you want coffee? No. And if I went down my list of 5 different things, then maybe I'm just fed up with the person. I always give them water. It's my last case scenario. Cool. Okay, great. So I think we've got that. And so the next thing we're going to get into is like I'm just going to show you how to make generating Booleans, because this is important. So now that you know like how to do a little bit of logic control, the next thing that you want to know is you're going to want to know how to make these Booleans up. Because, for example, I gave you these Booleans, right? I can just control these very, very straightforward. I can say, okay, Python is true right now, and I go to run that, and I get Python's great. But so what if I don't know in advance, right? So when you're writing a program, oftentimes you want the program to be able to figure out if something's true or false. Now, this is just kind of like basic ideas to get the wheels turning. In a lot of cases, you're going to be working with functions that will have like complex ways of determining whether to spit out a true or false to you, and then you can put those into your if statements. But so this is just an idea of how to generate some, how you would go to generate your Booleans, right? So you say like 1 is less than 5. So of course I'm just going to comment this stuff out. Run this. I'm going to say true. So yeah, of course 1 is less than 5, and so 1 is greater than 5. So that's of course false. Now we can say 1 is less than or equal to 5. We run that, we get true. Right? Another thing we could do is say 5 is less than or equal to 5. Of course, 5 is less than or equal to 5. We just got another couple to go through here. So we've got 5 is equal to 5. And you notice I use 2 equal signs here, because when we use 1 equal sign, this is how we put the information in a variable. right? So if we want to say are two things equal to each other, we want to check if two things are equal to each other, we just have to use two equals. So we run that, of course we're going to get true, and the last thing we've got is we just got not equal, right? So 5 does not equal 5. Of course that's false, because 5 does equal 5. And if you are wondering about if you ever are wondering about the syntax for any of that, super easy, just quick check on Google, of course. So this is some ideas, you know what I mean? So we're just going to kind of do a little silly example now. We're going to say example. Oh, actually, let's do, yeah, we'll do a really quick little example. Example, roller coaster height checker. There we go. Great. So now we're going to go. We're going to say, let's say height restriction equals 4. So I'm kind of just like, computer is making lots of noise. Okay, great. So height restriction, and then we'll say height of rider equals, I don't know, 5.2 feet. Or we say if height of rider is greater than height restriction, print, you get to ride the roller coaster, else, print, sorry, come back when you're taller. Okay, great. So that's a little silly example, right? And that's just kind of making my point here, is that if you have, let's say, a height restriction in feet, so the person has to be at least 4 feet to ride the roller coaster, and then you get the height of a rider, it's going to compare these two here, right? Height of rider is going to be 5'2", and of course that is higher, that's taller than the height restriction, and then they're going to get a true here. In that case, if you run this, you get to ride the roller coaster. So I think we can comment this out, run this, get to ride the roller coaster, and of course if this person is a little short person, child, sorry, come back when you're taller. Cool. Okay, so next thing we're going to get into is we're going to get into loops and iteration. So basically, like I said with my friend, when I was helping her write this script to kind of automate some of her work for her, I basically want to figure out what did she need to do to check one person. So basically her job was that she had to go and look at all these different patients' files, and she had to figure out if a certain kind of conditions were met, then she needed to make an appointment for them because they were, let's say, they were due for a checkup, right? So she'd have to check their blood pressure and check how their weight was going and check a bunch of other variables. And if, a couple of them were true, let's say, then she would make an appointment for them. So I'd kind of figure that out for one person. And that's basically what I would do with a bunch of these different if statements and generating some Booleans. And I could figure out if it was true for one person. But then, of course, I don't want to have to retype the code over and over for like all, I think it was like over 100 people that she needed to do it for. It was a huge number of people. So what I want to do is I want to get the computer, now that I figured out the logic for one person, I want to get the computer to do it over and over and over for me so that, I can go do something else. So this is kind of where we get into iteration. Iteration just means doing something over and over and over. And similarly with loops, it's just over and over. So I'm going to introduce you to a couple little prerequisite things, and then we're going to get into this stuff. So first of all, we're going to go with lists. And the syntax for a list is, let's just start off with a very basic list, and we're going to go, let's give it a good list of names equals, so the thing is we're going to have some square brackets. We're going to go with Alice and Bob and Carol. These are kind of your textbook names, so a little bit boring. No offense to any people named actually that, but they're ABC, as you can probably guess. So cool. And then we're going to go with list indexing. Okay, cool. So what have we done here? Just give me 1 second. We'll come back to this. So basically, we've talked about variables before, and variables are kind of our most basic data structure. And the data structure is just kind of something that's going to hold on to some data. Basically, because I said before, you give the computer data, give it some rules, it's going to process that data, and then it's going to give you something back, right? It's going to execute the functions or whatever. Anyway, so in this case, we are now moving past variables to a different kind of data structure, something that can, again, hold data. But this one can hold as many pieces of data as you want. Variables only held one piece of data, right? So like height restriction equals this, only one piece of data. If I try to put in more pieces of data like this, it's going to complain at me. and it's going to break fundamentally. But if I wanted to put in a bunch of different heights, for example, I could put them into a list, right? So this is just holding a bunch of names, but I could, of course, I could add numbers in here. I could add Booleans in here. Python's really cool because it will basically store whatever you want in lists, unlike other languages. And so, for example, if I want to access an item inside the list, I'm going to go list of names, and I can just go 0, for example. We're going to comment this out again, and then we're going to go run, and it's going to print out Alice. So the idea is that this always surprises people a little bit if you're not have a computer science background, is that we start counting at 0 for whatever reason. And so this is, instead of this being the thing in position 1, it's the thing in position 0, and this is 1 and this is 2, right? And if I were to go look for something in position number 3, I would get an error, right? I would go run this and I would get an error, list index out of range. So basically the thing in 3 is actually here, right? It's like the 4th thing. So yeah, I hope that's pretty clear. If I want to get Carol out of this, I would go 2, right? Carol, 1 or 0, 1, 2. So that's pretty straightforward. The really nice thing about lists is they are iterables. And iterables means that I can run loops on them to do things over and over and over. So if I want to print out everybody's name, I could go 0, and then I could copy this. I could go 1, and then I could do it one more time. And that would, of course, print out everybody's name for me. But if I had like 1,000 names, that would take me a lot of copying and pasting. Oh no, not a 3. Sorry, yeah, not a 3. Clearly. So 0, 1, 2. That would print it out for me. But instead, what I'm going to do is I'm just going to have I'm going to actually leave the list indexing one example of it, anyways. Instead, I'm going to do a for loop, which is going to basically do it for me. So just like the if statements, we're going to see that this goes to for. And we're going to say name in list of names, print name. Comment this out again. Cool, so this is just doing it for me. So what's this doing? So it's basically saying we're creating this new variable, and this is kind of like an ephemeral variable, meaning that it's only going to exist inside this for loop, right? So this is not a variable, because I already actually have name up there before, so I guess that's a bit confusing, but basically I'm going to name this, I don't know, I don't want to be confusing there, but basically what it's doing is, in this case, it's this name variable is overwriting the one I had up here. Where it was Nicholas, it's just overwriting that. Great, okay. So basically what it's doing though is it's taking this name, and it's for so each time it goes through the loop, it actually is taking on the next element in the list. What I mean by that is it's first going to start off being Alice, and then it's going to go through this loop. Then the name is going to turn into Bob. It's going to go through this loop, and then it's going to turn to Carol, and then it's going to go through this loop. Right? And that's exactly what it's doing, right? At first it starts off as Alice, and then what does it do? It prints Alice, and then it goes to the next person, it goes to Bob, and it prints Bob and Carol, right? It's pretty straightforward stuff here, but if you are kind of like, why, this syntax is a little bit to wrap your head around off the start, but that's basically just it, right? So it's just for each name in the list of names, but it's going to do it one at a time, and it's going to print them out like this, right? So that's pretty cool. So one thing we could do is kind of to keep putting this stuff together, we could create, I'm just going to comment this out again, and I could say, for example, list of heights equals, spelling that right. We created a list here, and we could say, I don't know, 3.2 and 5.6 and 6.1 and 2.2 and a person who's even 4 and somebody who's 5. Okay, great. Also, we're going to make this. We're going to come up here, and we're going to get our silly little roller coaster thingy. Right, we're going to uncomment that. We're going to cut that. So we're going to say for, let's say, rider in list of heights, this colon, then we're going to paste our code, right? We're going to come down here. We're going to get rid of this. We don't need this height of rider anymore. Here, I'm going to type it out, and then I'll come back and we can sort everything out. Well, we'll just leave that up there. We know it's 4. We've got to be over 4 feet tall, right? So we're going to go, in this case, we're going to change this to rider. Cool. Okay. So what did we just do here? So I think everybody kind of has an intuitive idea, but I'm going to really just like slowly walk through what we just did here so that it's not at all confusing. Basically, remember how we had this little function up here before that would take the height of a rider, right? And the height of the rider was, in this case, it was 3.2 feet tall, let's say, and it compared to this to height restriction. And if it was taller, they say you get to ride the roller coaster. And if not, they say, all right, come back when you're later. Or sorry, come back when you're taller, kind of thing, right? But now let's say I have a whole bunch of riders, right? And I've got all their heights. So instead of having to like type this code over and over and over like this, I can just say for rider, right, in list of heights. So it's going to start off by being 3.2, then 5.6, then whatever. And it's going to run them through this logic over and over. So when we go to run this, and we go to print this, we're just going to get a whole bunch of different statements where it's just checking if the people can write or not, which is kind of cool, right? And so that just kind of saves us a whole lot of work. Cool. Let us go to, yeah, I think I'm going to just do, so I'm just going to show you a couple things called just like getting fancy part 1. There's going to be part 2 of this. So basically I'm just going to show you something called list comprehension. List comprehension. Am I going to spell that right? It's like not even close, right? List comp. Oh god, how do I spell this comprehension? It's embarrassing. It's embarrassing. Forgive me, guys. List comp. See, this is why I'm a programmer, not a speller. Thank God that job doesn't exist. Okay, great. List comprehension. So the reason I'm showing this is just because excuse me, is because if you go on and you're coding and you're going to start like trying to do your own little projects and stuff, you're going to see list comprehension. It's very common, but it's a bit of a fancier way than writing a loop, right? So we had this loop like this. I'm actually going to uncomment this. So we have this loop like this, and it's on multiple lines. But let's say I wanted to print out the heights of the riders only if the height is over, I don't know, 6. So I want to really quickly just see, like, I want to print height for height in, I'll just type it out and then I'll come back to it, list of heights, if height is greater than 6. Okay, we're going to get rid of this now. So what do we just do here? So this, if you saw this, you might be like, whoa, like we haven't covered this before, and you will see this a lot, list comprehension. And the idea is just that instead of writing this loop on multiple lines, I've now, well, it's not the same loop, of course, but I've written, this is just how to write a loop on one line. So when in Python, people have done certain things so many times, they create shortcuts so that you don't have to do it don't have to do it a long form way. So when you're learning, you want to learn it the long form way. You want to write it on multiple lines so it's clear to you and you can think through it. But what I've just done here is I've written a loop all in one line. And so what this loop just is doing is it's just saying, print the height for height in list of heights. So basically it's just like a for loop where we've got for rider in list of heights. In this case, I'm calling it height. So I should have been consistent here. Maybe I'll say, I should have changed it to be height here, but whatever, it doesn't matter. But the idea is that for each height in list of heights, so it's going to start off by being 3.2, then 5.6, then 6.1. It's saying I want you to print that height if that height is greater than 6, right? So I think in this case it only has 1, so if we go to run it, it's just going to write 6.1, right? So it's going through here, it says 3.2. Okay, 3.2, because that's the first height in list of heights. Is it bigger than 6? No, so then don't do anything, right? But as it gets to 6.1, it says 6.1 in list of heights, so that's a height in list of heights. Okay, we're looping like we learned before. If that height is greater than 6, then, and it is, of course, so this turns to a true. Is it true? Then print that height. Right, you can see how I've just jammed my control logic and my loops all into one line. And it's just a nice opportunity to have, or it's nice to be able to write like that when you're writing quickly. But at the same time, I want you to see if you're new to it and you go to read on Stack Exchange and you see list comprehension, you're like, I don't get that. Now you do at least understand that, hopefully, if I'm being clear so far. Great, so we're just gonna get into, the next thing we're gonna do is we're gonna start making our own functions, right? So far we've been using what are called built-in functions. So built-in functions are functions that come with Python. Generally when you're using a language, for example, generally when you're programming, for example, you're going to be using other people's code. To get that other people's code, you first download it off the internet, and then you pull it into your program that you're writing. We're going to cover that at the end, and I think we have just enough time to get through that. So basically that's programs. So there's basically, you can think of programs of almost there's going to be 3 types of functions, and this is a very, like, this is just, don't hold me to this. This is just for like teaching purposes. This is not the way that you should exactly think of it, but you can think of basically functions that come with Python that are always there. Like print is always there, len is always there, the string methods I showed, they're always there, right? The next kind of functions you can think of are functions that you're going to import from external sources, right? And these are libraries of functions that there's libraries of code you're going to bring off the internet and then you're going to put into your programs, kind of thing. And I think the third class of functions you think of are functions that you've written yourself, right? So now that we've used something like, let's say, print or len, right? Print, obviously, I'm not just like, basically in the background, Python has a bunch of code that's kind of probably fairly complex that is going to make whatever data I give to print show up in my terminal at the bottom here. This is called like my terminal, fundamentally. So basically, and len as well, right? Len, you can imagine maybe in the background, right? So if I say len name, for example, I think we know that turns into 8. You can almost think there's maybe a for loop there, where the for loop is counting each time it sees a character, and then it's returning that number of characters. But there's some code in the back, right? So now, obviously, if you're following along with me and you've seen how we can use control logic and loops a little bit, we can kind of get into writing our own functions, right? So now what we're going to do is we're going to write our own function, which is pretty good, and it's a pretty great next step. So we're going to say def. We're going to call it height checker, and we're going to take a we'll say list of. I'm going to change this around riders heights to not be confusing, and we're going to say height restriction in feet. Cool, and then and you kind of are recognizing the syntax here, right? Starting off def, that's kind of like telling Python what's about to happen, and then I'm going to give it some kind of name here. Actually, I'm going to code it out, and then we'll kind of get into what it's doing, right? So we're going to say we're going to take this code once again here. We just kind of keep taking this code and reusing it, and I'm going to uncomment it, and now I've got to tab it all over. So I'm doing a lot of stuff here, and I'm going to come back and I'm going to try to explain it. And if there's any questions, right, if I forget anything, please let me know. And then we're going to say, yeah, I think that is going to be it. Now we just need to change these around a little bit. We're going to say list of rider heights for, let's say, height. In list of rider heights, if height is greater than height restriction in feet. Pretty good blah blah blah. Okay, so I think that's going to work for us. And so I'm just going to make a little bit of a doc string here. I'm going to say takes a list of heights and height restriction. I should say, I should just call that int. Let's call that float. And prints if height is, I don't know, prints if person can ride the roller coaster. Great. We're super excited about roller coasters. Okay, this is a bit silly, but let's go with it. Okay, so what have we done here? So basically, I've created my own function, right? And the way I would use my function is just like I've been doing print, and I've been giving it some data. I'm going to call the name of my function. I'm going to call height. I'm just going to write height checker, or height checker. And so we'll notice that print and len only took one piece of information. These are all parameters, basically. And parameters are kind of the variables that you need to put into your function. So just like before with print, I needed to say what it was going to print, right? Or len, I needed to give it the variable that it was going to count how many characters were in, right? In this case, I know I need to give this height checker, I need to give it a list of riders, heights, and I need to give it a height restriction in feet. Now, I purposely changed the names here so that you know that these parameters, these are just kind of like dummy variables. I could call these anything. I could have called this, L of H, and that would have been like perfectly suitable as long as it matched down here in my code. So you'll see what I mean in a second here. So if you've written functions before, none of this is very surprising to you, but there are some beginners, so I'm going to go through kind of slowly. So list of riders heights. Basically what happens is the list of riders heights down here. Once I can pass in any list of riders heights, and that list of riders heights will then be used in my logic here. You notice how these two variables match, right? And then you'll notice height restriction in feet matches this one up here, right? Or at least it should. Yeah, it does. Okay, great. So height restriction in feet, right? So whatever I put in there, it's going to match that, and we're going to check. So let's run this. Let's see if it works. Okay, so we're going to say we've got our list of heights up here. So we're going to put in here list of heights, and then we're going to say we've got our height restriction up here somewhere. we've got height restriction. So let's put on our height restriction. Cool. Now let's run it and see what happens. See what we're doing. Okay, great. So basically, this is now a function that we've written called height checker. And obviously, this is not a function that's going to come with Python itself because one, it's fairly silly. It's not very, it's not a very good function. There's going to be a lot better function, but I just made it up kind of on the fly. But so this is the function that we use. So if I ever had, let's say, a whole bunch of new lists, or let's say each day, a new list was being generated. So from the internet somewhere, I had these lists coming in. I could just keep popping them into my function over and over and over, and it would keep doing the same logic over and over and over. And that's really, really cool, right? Just like print, every time I want to go print something, I don't have to fiddle around and write a bunch of code in the background to get it to work. It just works for me, and I can just call the one word, right? So it basically takes all this logic, which has a for loop, it has got some control statements and stuff like that, and it just means that every time I want to execute this logic on a list with a height restriction, all I have to do is call the name of it, pass it the list, pass it the height restriction, and it's going to start working. So I hope that's really clear. If it's not, please let me know and I can try to explain that more, but that's pretty much it, right? Like now I've made my own function. You can make unlimited numbers of functions. So the last thing we're going to cover just really, really quickly, because we are running out of time, is how to import and use other people's functions, which is sort of like the power of Python. And I'm going to I have 6 minutes. So I'm going to do my intro to machine learning example really, really fast. And we're just going to ignore, actually we'll copy all of this over here. So I'm deleting everything so far. And yeah, okay, great. So pandas, TensorFlow, NumPy, Matplotlib, and pandas. Okay. This, and we're gonna get rid of this. Cool. So basically, this, again, if you haven't coded much before, is gonna look all pretty overwhelming, or what have you. So yeah, okay. So basically this is, the reason I'm posting these things at the top is whenever you're going to use other people's code, you basically write it at the top of your, program. So you put your import statements at the top. So what's going on here? Okay, so let's just focus on this first line here. So I've done this. So it's grayed out right now because I haven't used TensorFlow, but I'm going to write this down here so it stops being grayed out. Okay, cool. So basically what I've done is TensorFlow is Google's library for machine learning. Machine learning, again, powers a lot of like the modern artificial intelligence stuff, and it's really, really powerful. It's really wonderful. It's really worth checking out. And it's really beautiful, I would say, and it's, it's kind of making machines much more intelligent as they go along. It's what's powering self-driving cars. Every time you talk to your phone and it recognizes your voice, it's doing that. Every time you get served ads on Google or the internet, as annoying as those ads are, they're very targeted because of machine learning. It's very, very powerful, and a lot of it, of course, is built in TensorFlow, which is a free library to do machine learning from Google. Okay, wow, that's pretty cool, right? So how do we use TensorFlow? Well, obviously we have to learn how to use it. We have to learn machine learning, and there's some learning that has to go on there. But in the case that we do know it, what are we going to do? So in Pycharm, we're going to go to File, Settings, and then we're going to go to Project Interpreter right here, right? And then we're going to go on the plus here. And these are all the different libraries that we can download. There's a lot of them, obviously, and all of these have code in them that doesn't come with Python, but will do some specific task for you, right? I don't know what 99% of these do, but I do know a couple decently well, right? So in this case, I would just type TensorFlow in here, TensorFlow, and I would be getting the TensorFlow library, right? Open source machine learning framework for everybody, and it's created by Google. So pretty cool. So I go install packages, and it would install. I've already done that, so I'm not going to, right? So I would close this, and then I would see these are all the packages I have installed right now, right? And so I could cancel out here. TensorFlow is going to be in here somewhere. I would cancel out here, and so cool. So now TensorFlow at that point is downloaded onto my computer, but it's not working in my program yet. So I could have many different little scripts going, and I might not want them to all be running TensorFlow. The reason I might not want to be doing this is because each time I bring a library into my program, it takes up, space, and so it slows everything down. So in this case, I'm going to actually have to say import TensorFlow, and that means that this program, this little program I'm writing, knows that it's going to be using TensorFlow, right? Now, the thing, yeah, okay, sorry guys, we are definitely out of time. I'm sorry about the scheduling error. I should definitely just close up right now. I'll just say that this is one thing you would definitely want to learn is TensorFlow. The convention is you'd go as TF. This is just a short form, so I'm going to bring TensorFlow in. But every time I want to use it, instead of having to write it TensorFlow here, I'm just going to write TF just because it's short formed. that's pretty much it. This was a little cool machine learning example, just a couple little lines of code, and I can actually get the computer to recognize handwritten digits, which is something that's incredibly, incredibly difficult to do. I don't have time to explain why, but basically having a computer, if I show a computer a picture of a 2, and I want the computer to be able to tell me that it's a 2, you know what I mean? Like somebody wrote a 2 out. It's very, very difficult to do, but we can obviously do that very well these days. It's kind of a recent development. So anyways, don't have time to explain that. But yeah, if you guys join us, if you join me next week, even if you just jump in right at 6, from basically 6 to 6:30, I'll be going through a bit of machine learning. And yeah, if anybody wants kind of like next steps to do machine learning, we do run courses for that where we'll kind of like, we do a boot camp of the weekends, and we're kind of getting ramped up to do a lot more longer form course. It's taught by like a 15-year veteran who knows a lot about machine learning, and he's used it to definitely build some amazing products. And there's a lot of people talk about machine learning being the new electricity, because just like back in the day, everything that we kind of built got just better and worked better when we gave electricity to it. Similarly with machine learning, everything, all of our technology, all of our programs, as we kind of integrate machine learning into them, in as much as there's a place for that, then they're going to work better and be more intelligent. So yeah, it's a really wonderful thing to learn about. So I'm going to kind of have to leave it there though. And yeah, I hope this is good for people. I hope you learned a little bit. I hope it wasn't too dry and too slow for the people who've already programmed a lot, and I hope it wasn't too fast for the beginners. But yeah, it's been really nice talking to you guys, teaching a little bit. And yeah, we have an event actually right now coming up. That's why I have to jump off right now, called How to Become a Software Developer. And yeah, you're also very welcome to join on that. It's the next meetup right after this one. If anybody wants to become a software developer, get a job in software. Anyways, I hope you all had a great time, and yeah, hope to see you soon. Okay, bye bye.